Hello everybody, welcome back. I'm just going to quickly go through the 6 arithmetic maths questions for today. I'm going to go very quickly. I've already started doing the workings out just to save a little bit of time for you guys. Okay, so question number 1, 5.07 multiplied by 100. You know that when you're multiplying by 10, 100 or 1000, you move all of the digits to the left because you're making them bigger. We use the dots method. Now there are 2 zeros in 100, so put 2 dots below 5.07, ensuring the decimal points are lined up correctly, and you're moving them 1, 2 places to the left, so your answer would be 507. Okay, so 7.5 plus 3 2/3. I've put a little steps to success up here. Now you're adding together two mixed numbers. So the first step you need to do is multiply the denominator by the whole number because we want to turn this mixed number into an improper fraction. So as you can see here, step number 1, times the whole number by the denominator, which is 14, and add it to the numerator, which is step number 2, which gives us 15. Now the denominator must stay the same. So that turns into 15 over 2. For this mixed number here, again, multiply the denominator by the numerator, by the whole number, sorry, and add it onto the numerator, which gets you 11 over 3. Now, the problem is still that the two denominators are different, so we need to make them the same by finding the lowest common multiple. So if I start by doing my 2 times table, 2, 4, 6, well, I know that 6 is in the 3 times table, so I'm going to stop there. I'm going to then turn this 3 into a 6, and I'll do my 3 times table, so 3, 6. So I've multiplied this 3 by 2 to get 6. Now just remember that when you're finding the lowest common multiple, you need, whatever you do to the bottom, you must do to the top. So I've multiplied this 2 by 3 to get 6. So I must also multiply 15 by 3. So here will give you 45. So 45 over 6. I must do the same with this fraction. So I've multiplied this denominator by 2 to get 6. So I've also got to multiply the top, the numerator, by 2. And that gives me 22 over 6. So now the denominators are both the same. I can now add these two fractions together. That will give me 67 over 6. Now, because both of these originally were mixed numbers, we need to convert it back into a mixed number, which gives us 11 over 6. And the way that we do that is by seeing how many 6's go into 67. Well, I know that 6 times 11 is 66, but I would have a remainder 1. So the 1 would become my new numerator, and my denominator always stays the same. If you have any questions about that particular question, please comment below on the YouTube video. Okay, 2,200 divided by 16. Now this is long division, so bear with me. 2,200 needs to go into the bus stop first of all, and the 16, the divisor, goes on the outside. So first of all, how many 16s go into 2? Well, 0. How many 16s go into 22? Well, I know one 16 goes into 22, so I'd put 16 below the 22 and subtract it, which then gives me 6. Now I need to drop down the next digit, which is the 0, next to the 6 to create a 60, because if you think about it, when I'm doing my short division, if I had a remainder 6, I'd actually put it in front of the 0 to make a 60, but in long division, to make it easier for ourselves and so it's clearer when we're doing the workings out, we drop that 0 next to the 6 to make a 60. Now this is where it gets a little bit tricky, because my 16 times table, we don't practice that in school, we only go up to our 12s, so to make it easier for ourselves, I then here on the right hand side have partitioned the number into 10s and 1s to make my 16 times table a lot easier to calculate. So if you look here, for example, a 10 and a 6 added together equals 16. This side here, this column, I'm going up in 10s, I'm doing my 10 times table, and here I'm doing my 6 times table. So 20 is the next sequence in the 10 times table, and 12 is the next sequence in the 6 times table. I'll then add them together to get 32. So that's the next sequence in the 16 times table. I hope that makes sense, guys. You have practiced that in school quite a lot this year. Okay, so I know that in 60 there are 1, 2, 3 16s, so I put my 3 up here, and then I'd put whatever I got up to, so 1, 2, 3, I got up to 48, I'll put my 48 below the 60 and subtract it, which then leaves me with 12. Again, I'm going to drop down the next digit next to my 12, because that's my remainder, to make 120. So now I need to see how many 16s go into 120. Well, if I go back to my partitioning method to do my 16s times table, I know there's 1, 2, 3, 4, 5, 6, 7 16s in 120, because remember I don't want to go beyond 120. So I've got 7 16s in 120. So I put 7 up here, which gives me 137. Now, I do have a remainder. I have remainder 8, because if I subtract that 112 away from 120, it leaves me with 8. Now, this is where things get a little bit tricky. So, if I imagine this as a whole number, and I know that beyond the whole number there's always an imaginary decimal point. So I put my decimal point in, and I put my next digit, which will be in the 10ths digit, which is a 0. So then I would drop that 0 next to my 8 to create 80. Now I must remember to move that decimal point up and put it next to the last digit on top of my bus stop. So I can now see that I'm left with 80. And going back to my 16 times table, I know there's 1, 2, 3, 4, 5 16s in 80. So I put my 5 up here, and there are no remainders, so there's nothing for me to take away from the 80. So my answer is 137.5. Again, I know that I was going at some speed there. So please, if you have any questions about long division, please get into contact with me. Okay, so slightly easier question. 10 cubed. Well, we know that cubing a number means timesing it by itself 3 times. So 10 times 10, I know, is 100. And then if I times that 100 by 10, I get 1,000. Now, that's only 10 cubes, so that's half of the question complete. And remember, I still need to take away 1. So, using the formal method, I'm taking 1 away from 1,000. You can do this a number of ways. I'm just going to show you using the formal method. A lot of you can just do this mentally by counting 1 back from 1,000, but using this one, 0 is bigger than 1. So I need to go next door. There's nothing to borrow next door. So I'll go to the next door neighbour. There's still nothing to borrow. So I'll then finally go to my final digit and borrow 1 from there. So that becomes a 10. Then I start my process again. I'm going to borrow from next door. Can't borrow. So I'm going to my next door neighbour. That's a 10. Brilliant. So I'm going to take 1 away, borrow 1 from the 10. This becomes a 9. And this next digit becomes a 10. Fantastic. So I'm going to start the process once again. I'm going to borrow from next door. Take 1 off. That becomes a 9. I'm then going to make this 0 now a 10, because I'm exchanging from this digit into my 1s. So then I can now finally take 1 away from 10, which makes it 9. And then I'm going to drop these digits down because there's nothing to take away from them. So my answer would be 999. Now, like I said before, some of you would have done it much quicker than I've just shown you, but I've chosen to show you using the formal method. Okay, so mixed number multiplied by a whole number. First thing that I need to do, you've guessed right, I need to change this into an improper fraction. So I'm going to multiply the whole number by the denominator, which is 15, because 3 times 5 is 15, and I'm going to add it to my numerator. So 15 add 4 equals 19. over 5. Remember, the denominator must stay the same. I'm then going to multiply it by the whole number, and we know that currently this whole number is 3 over 1 as a fraction. And when we multiply fractions together, we multiply the numerators first, so 19 multiplied by 3. You might need to use a formal method, but it equals 57, and then 5 multiplied by 1 equals 5. Now, because, again, we started with a mixed number, we must convert this improper fraction back into a mixed number again. So, finding how many 5s go into 57, well, I know that 11 times 5 is 55, so 11 5s can fit into 57, but I have a remainder 2, so that becomes my new numerator, and then my denominator again stays the same. Guys, I'm going to repeat myself. If you find that challenging or you want me to explain it in more detail, please comment below. Going on to our final question. We know that the lovely people who design these tests have just flipped the answer box to the front, so it's in a different order, and that sometimes confuses certain children, but it's still exactly the same. You're going to take away 639 from 5,572. So I've set it up here in a formal method, and I've already done the workings to save time, so I'm not going to go through that because you guys should be really secure with taking away using the formal method. But again, like I said before, just leave a comment below, but your answer will be 4,933. So here are the 6 answers for today's arithmetic questions. Pause on this page, see how many you got right out of 6. Comment below if you feel comfortable doing that. If not, you can either message us directly on Twitter or just put a comment below, a generic comment just saying how well you've done without revealing your score. Completely up to you. Please get into contact if you want me to go over any of them. More than happy to help. You know, that's my job at the end of the day, is to help you guys to understand the different skills that we use in maths and across the curriculum. So yeah, guys, please get into contact. Well done if you gave that a go today. Super attitudes from everybody here in year 6. So it's great to hear from you guys today as well. I'll see you tomorrow morning for another 6 daily arithmetic questions.